Hello, this is Chien-Yi from Microsoft. Today, I'm going to introduce you our paper, Local Adaptive Face Recognition with Graph-Based Meta-Clustering and Regularized Adaptation. The Local Adaptive Face Recognition LaFR problem aims to optimize specialized face recognition models for certain environments. For example, adapt the models to recognize certain demographics or certain sensors. Data are limited and unlabeled in the adaptation environments, so that it is an unsupervised adaptation problem in face recognition. In our setup, we also integrate the pipeline with federated learning framework, which enables the continuous learning and further improvements of local and global models. Some previous methods aim to solve the unfair face recognition by debiasing the demographics information from the general face embedding. However, optimizing a general face representation which can generalize everywhere is not feasible in many deployment scenarios. In our setup, we would like to adapt and add bias to produce specialized models with optimized performance. Another line of work produce more generalized face representation by meta-learning, which can perform better in unseen environments. Our work can complement with it to produce better local models while we have the access to the local unlabeled data. There is one related work also addressing the unsupervised adaptation for face recognition. However, the distance-based clustering method is not robust enough and will require more hyperparameters. It also suffers from the need of labeled source data during adaptation. In contrast, our method proposes a better clustering method with Graph Convolution Network and does not require source data during adaptation. This is the overview of our framework. The first part is the meta-cluster model training, and the second part is the local adaptation. Graph Convolutional Network (GCN) is suitable for face embedding clustering problem. With the pre-calculated affinity graph to extract the feature distribution on local embeddings, the GCN could infer the confidence of the connectivity and obtain the cluster through minimal computational resource. We propose to apply meta-learning on the GCN to learn more generalized clustering model. During the training process, the domains are randomly shuffled in each epoch, and one domain is assigned as the meta-test domain. The second-order gradients from the meta-test domain are also backpropagated, so that the clustering model can be optimized with better generalization ability. During the model adaptation stage in unseen environments, the pseudo identities label are obtained by the well-trained clustering model. Then in the adaptation stage, the pseudo label are used to initialize the classifier weights by our regularized center transfer method. The center of embeddings extracted from the pre-trained model could well represent the corresponding identity. Furthermore, the weight regularization term is applied to reduce the risk of overfitting, while there are not much identity in the local environments. In the local adaptive face recognition experiment, there are 3 stages in each protocol for the comprehensive evaluation: training, adaptation, and evaluation. We first conduct adaptation experiments on different races. We evaluate the face embedding clustering performance with our proposed meta-GCN cluster method. It shows that our clustering method has better generalization ability than previous methods. In these 2 tables, we also demonstrate the effectiveness of our proposed framework for adapting onto unseen environments. Besides the adaptation experiment on different races, we also conduct experiments on 4 different inferior sensors to verify our proposed methods. We also incorporate the federated learning framework to further improve the global and local models. At the round T of the federated learning process, the local optimized model parameters are sent back to server for averaging aggregation. Then it could conduct another round of local optimization through the same adaptation process. In the result table, it is verified that the continuous learning with federated learning framework could improve the local models further. This set of protocols also demonstrates that our proposed method can also work in the environments with a few identities. This is our conclusion, and thank you. Feel free to contact me for any question, and welcome to our process session on Friday.